Here we have AP calculus AB problem. Okay, let's go to the information. Find all open intervals on which f of x equals to x cube negative 13 over 2 x square negative 10x positive 4 is decreasing. Okay, so according to the question, I have to find the open intervals where the graph of the given function is decreasing. So whenever I want to find the interval of increasing or decreasing for the given function, so my first step is to find the domain of the given function. So here the domain of the given function is all real values because here it's not a rational function, it's a regular polynomial function. So the regular polynomial function is different for all real values of x. Okay, now what I have to do is I have to find the first derivative of the given function, and then the first derivative has to be equated to 0. So for example, when I equate the first derivative to 0, I am getting two values for x. Just for an example, I am saying x equals to a and x equals to b. Now what I have to do is I have to mark these two values on the number line. So say a is less than b, then a should come first and b should come next. And the left side extreme is negative x infinity and the right side extreme is a positive infinity. So using these two values of x, I can split up the real number line into three intervals. The first interval is negative infinity comma a, and the second interval is a comma b, and the third interval is b comma positive infinity. So here I have taken all the three intervals as open intervals because I have just used parentheses. Parentheses means the boundary value should not be considered. For example, if I consider this particular interval, any value greater than negative infinity less than a should be considered. The boundary value a and this negative infinity should not be considered. The same thing, that is any value between a and b can be considered. So the boundary values cannot be considered. So that's called open interval. Okay, now to check, now to find the interval of increasing or decreasing for the given function, I have to check each of these three intervals with f prime of x, that is the first derivative of the given function. So for example, when I take a particular interval and I take a random value for x in that interval, I plug in that value for x into the first derivative. If the first derivative becomes positive, that is greater than 0, then the graph of the given function is increasing in that particular interval because the slope is positive. So in case when I plug in the particular value of x into the first derivative, if it becomes negative, so that is less than 0, then the graph of the given function will be decreasing because the slope becomes negative. So this is a concept of finding increasing or decreasing intervals for a function. Okay, now let me do the same stuff for our function. So already I said the domain of this function is all real numbers because I said I'm talking about the domain over here. The reason is, so for example, if there is a rational function, some values might have been excluded from the domain. So for example, let's say the domain of a particular function is all real numbers except k, that is k has been excluded from the domain. So when you give the interval of increasing or decreasing for the given function, so the same k has to be excluded from that interval. So that's why I'm saying we have to get the domain, but here we don't have any trouble with the domain of this function because it's not a rational function. So rational function means it will contain the variable x in denominator. It's a regular polynomial function, so for all real values it's different. So no real value has been excluded from the domain. Okay, now anyways, let me write the stuff for domain of this function is all real values. Okay, now what I have to do is I have to find the first derivative of the given function. Let me write the function as it is. It is f of x equals to x cube negative 13 over 2 times x square negative 10x positive 4. Okay, now let me find the first, let me make some changes. Okay, now let me find the first derivative f prime of x. So when I find f prime of x, it will become 3x square. I just use the power law of derivative. I bring this exponent 3 in front of the variable and subtract 1 from the exponent. So here negative 13 over 2 is a constant multiplied by the variable. When I find derivative, if there is a constant multiplied, I have to keep the constant as it is and I have to find the derivative of this x square using the power law of derivative. Then I'm getting 2x. Then again negative 10 is multiplied by the variable, so I have to keep this negative 10 as it is. When I find the derivative of this x with respect to x, it will become 1 positive. The derivative of this 4 is 0. This 2 and 2 will cancel out. I'm getting f prime of x equals to 3x square negative 13x negative 10. Okay, now what I have to do is I have to equate this first derivative to 0 and solve for x. Then I'm getting 3x square negative 13x negative 10 equals to 0. Okay, now it's a quadratic equation. What I have to do is I have to solve for this quadratic equation. So I think this quadratic equation can be solved by factoring. So for that, we have to multiply the constant of negative 10 by the coefficient of x square 3. So when I do so, I'm getting negative 30. Now I have to get two factors for negative 30. So that sum of the two factors equals to the coefficient of x, that is negative 13. I think negative 15 and positive 2 will work, because when I multiply negative 15 and positive 2, I am getting negative 30. When I add them, I am getting a negative 13, which is a coefficient of x. Okay, now to get the two values of x from these two factors, what I have to do is I have to divide both these factors by the coefficient of x square 3. Let me write it over here. Okay, so when I divide this negative 15 over 3, I'm getting negative 5, and this 2 is not divisible by 3, so I have to write this positive 2 over 3 as it is. Okay, now to get the two values of x, what I have to do is I have to change the sign of each of these two factors. When I change this negative sign, I'm getting positive 5, so that's the first value of x. When I change this positive sign, I'm getting negative 2 over 3, that's the second value of x. Okay, now what I have to do is I have to mark these two values of x on the number line. So here a negative value should write at first, it is negative 2 over 3, and the positive value should be next, and the right side extreme is positive infinity and the left side extreme is negative infinity. So using these two values of x, I can split up the real number line into three intervals. So the first interval is negative infinity comma negative 2 over 3, and the second interval is negative 2 over 3 comma positive 5, and the third interval is 5 comma positive infinity. All of them are open intervals because I used parentheses at everywhere, because according to the question we have to find the open intervals. So parenthesis means we should not consider boundary values in each interval. Like we can for example, if I take this second interval negative 2 third comma 5, I can consider only the values between this one and this one. I can never consider the boundary values negative 2 or 3 or 5, because we have parenthesis over here. So this is called open interval. Okay, now what I have to do is I have to check each of these three intervals with f prime of x. So now let's take a random value in this interval. So its value is approximately negative 0.666 or something. So let's take negative 1 in this interval, the first interval. Now what I have to do is I have to plug in negative 1 into this into the first derivative f prime of x. Okay, now let me plug in. When I do so, I'm getting 3 times negative 1 the whole square, negative 13 times negative 1, negative 10. So negative 1 whole square is just 1 times 3 is 3, and negative times negative will become positive 13, negative 10. So clearly this is positive. 3 positive 13 is 16, 16 negative 10 is positive 6. So when I plug in x equals to negative 1 into the first derivative, f prime of 1 becomes positive greater than 0. So when first derivative becomes 0, clearly in this interval the given function is increasing, but the question is asking us to find the interval of decreasing. Okay, now let's skip the first interval. So because in the first interval the given function is increasing. Now let me consider the second interval. So let's take a random value in the second interval. So obviously it's 0, because 0 is a value between negative value and positive value. Now let me plug in this 0 into f prime of x, that is f prime of 0 is equal to 3 times, so when I plug in 0, 0 square is still 0, negative 13 times 0, negative 10. So this will become 0, this will become 0. I'm getting f prime of 0 equals to negative 10, which is less than 0. So since the first derivative becomes negative in this interval, negative 2 third comma 5, so the given function f of x is decreasing in this interval. And also, anyways, we can verify the third interval 5 comma positive infinity as well. So the random value in this interval is clearly it's 6. When I plug in 6 into this f prime of x, what will happen? So when I plug in 6 into this one, let me evaluate it. This 3 times 6 square, negative 13 times 6, negative 10. The value of 6 square is 36, and negative 13 times 6 will be negative 78, negative 10. So 3 times 36 will be 108. So negative 78, negative 10. When I combine these two values, I'm getting negative 88. So clearly it's a positive value. So when I plug in a random value from this interval, that is 5 comma positive infinity, f prime of x becomes positive. So in this interval, the given function is increasing. So only in the second interval, that is let me erase the stuff out here. Only in the second interval, that is negative 2 comma 2 third comma 5, the given function is decreasing. So let me write the stuff over here. F of x is decreasing on the open interval negative 2 third comma positive 5. That is when x takes any value between negative 2 third and positive 5, f prime of x becomes a negative. So f of x, the given function f of x is decreasing in the open interval negative 2 third comma 5.